Flow Plus generates results of coupled simulation of mold filling and casting solidification. This module helps to understand the filling and solidification related defect. Filling result, it shows the sequence of metal filling in the mold cavity. Green color region on the casting surface shows the temperature drop. Filling time requirement for the given casting is 19.69 seconds and solidification time is 59.57 minutes. The velocity values can be displayed at any section during mold filling. The velocity values add-in gates help in verifying the gating design to analyze the mold filling related defects like sand inclusions. Liquid fraction analysis gives an idea about portions of the casting which are still partially liquid at a particular instant of time during solidification. It helps to identify the hot spots and assessing the pattern of feeding inside the casting. Isolated liquid regions have the chances of shrinkage porosity. To map the result of liquid fraction, we need to check the result of solidification and solidification time. Solidification result shows the temperature profile at the end of solidification. It helps to find out the temperature values at the isolated liquid locations. The user can estimate mold and core temperature values at any specific section. Solidification time result helps in understanding the relative cooling rate. Here we can see that the isolated liquid region is solidifying later as compared to the surrounding region. Hence the chances of shrinkage formation at that location is more. By the analysis of solidification and solidification time results, we can say that the directional solidification has occurred at the feeder region. Shrinkage porosity analysis helps to determine the macro and micro shrinkage locations and the volume of shrinkage porosity. AutoCAST also helps us to predict the depression shrinkage locations. Hard zones, it shows the rapid cooled regions. It suggests an area where hard zones occur during the machining. Thermocouple analysis helps to generate the cooling curves. By using cooling curve, the solidification behavior at a specific section can be analyzed. The user can place the virtual thermocouples in the casting as well as in the mold and core. It is a temperature time graph. These are solidus and liquidus lines for the given casting material. TC1 and TC2 represent thermocouples which are placed in the defect probable region and neighboring region respectively. Here, we can see the defect probable region is solidifying later when compared to the neighboring region. Hence, the hotspot is being formed in the defect probable region. TC3 and TC4 represent thermocouples which are placed in the feeder and connected part respectively. From the graph, we can say that the feeder is taking more time to solidify as compared to the connected part. Hence, the directional solidification has occurred over there. Blue and green lines show the heating curves for the virtual thermocouples which are placed in the core and mold respectively. Air porosity analysis. The user can see 100% of the air fraction at the beginning from the color map. As the metal fills the mold cavity, the air fraction percentage will be reduced. At the end, the user can find isolated air pockets where the chances for blowholes is more.